In the previous video we learned the component form of the vector in 3 dimension. If we have a vector, let's say R, and if we represent it something like, let's say x I cap, y j cap, and z k cap, then this form of the representation of any vector is called component form. All right, and based on this, now we're going to learn the algebra of the component form. All right, so let's say I have a vector A, right, which is let me say, all right, and I have another vector, let's say B, which is let's say x2 I k. Later we'll take number and then we'll solve further. Then first I'm gonna say how do you add this vector A and vector B in the component form. So always keep in mind, you can only add terms of similar nature. Similar nature means if it is I cap and I cap, then you can add them. If here if you see they are j cap and j cap, so you can add this both. Here you can see k cap and k cap, so you can add this. All right, so of the same axis only, like coordinates of the same axis only you can add. So this will be like finally x1 plus x2 I cap, and then it will be y1 plus y2 k cap, and it will be z1 plus z2 k cap. Right, and this is not only for the addition, this will work for the difference also. All right, if you're talking about difference a minus b, then again just change the sign here only, right, and this will be everything same. For example, let me say this is, let's say 2i plus 3j plus 4k, and here let's say 1i, you don't have to write 1 for that, 3j plus let's say 3k. Okay, and now I want to find a plus b, so that time it will be 2 plus 1 I, right, because these are similar I. Right, and next time you're gonna add these 3j plus 3j, it will be now 3 plus 3 j cap, and here this is 4 plus 3, 7 you can directly write, but I'm just showing you 4 plus 3 k. So a plus b vector will be now 3 I cap plus 6 j cap plus 7 k cap. All right, and if you find out vector a minus vector b, then that time simply differentiate the x coordinate, all right, and a y coordinate and then z coordinate. So difference of x coordinate, I mean 2 minus 1, it will be 1, right? You better write like this: 2 minus 1 I cap, and then 3 minus 3 cap, 3 minus 3 j cap, and then 4 minus 3 k cap. All right, so final result will be now 1 I. All right, you don't have to write 1 for that. All right, I cap plus 0 cap, so no need to write, and here is 4 minus 3, that is k cap, so simply it's k cap. Since this is 0 plus j cap, so you don't have to write that. All right, leave it, that's your answer. And now second one, let's talk about equality of component form of the vector. Vector a will be equals to vector b if and only if. IFF means if and only if x1 is equals to x2, y1 is equals to y2, and z1 is equals to z2. This is the condition when two vectors becomes equal. All right, if the coordinates, x coordinates, y coordinates, and z coordinates are equal, then that time we can say that two vectors are equal in component form as well. Now what happens if a vector in component form is multiplied by a scalar quantity? Let's say we have a vector a which is, let's say, xi plus yj plus zk, all right, k cap, and we want to multiply by a lambda. It's a scalar quantity. Then what happens? It's simply going to multiply all the coordinates by lambda. So lambda xi, lambda yj, and lambda zk. All right, in a similar way, if I have a vector, let's say vector a equals to, let's say, 3i cap, 4j cap, and 9k cap, and if I want to multiply by, let's say 2a, let's say 3a, all right, then that time it will be 3 times 3i cap, 4j cap, 9k cap. It means it's gonna be now 9i cap plus 3 times 4, that is 12j cap, and 3 times 9, that is 27, so 27k cap. simply it's gonna multiply all the coordinates. All right, that's it. And component form of the vectors, in addition as well as in multiplication, they follow distribution law. I mean to say, let's say k is some number, all right, some scalar quantity. It's ka plus let's say m times a. Here m is also a constant. Then that time you can take a common outside and it will be like k plus m times a. All right, similarly if you have, let's say, k times ma, all right, then you can simply write k times m first in a bracket and then a. All right, similarly in addition, if k is going to multiply a plus vector b, and a and b both are in the component form, then again you can distribute easily, ka plus kb, right? So these are the things you should consider before starting to solve the problems related to the component form of the vectors. All right, we'll see so many different type. We'll see, we'll try to solve many different type of the questions based on this component form of the vectors. And I hope you understand the things that I shared with you, and please don't forget to subscribe the channel and hit the like button. I'll be really happy. If you have any more confusion, any doubt, please feel free to comment below this video. I will definitely reply you back. I wish you a wonderful day. Goodbye.